Okay, so we start with well, we continue the exam revision again because it seems that people are not very interested in the tutorial. So now we continue with exam 2020. Okay, so now, so if you still have exam 2020 open, then that is the part C. And now part D is about divided difference. So suppose you are given so now the next question is, suppose you are given the divided difference coefficient f x1 x2, okay, and then f divided difference of f x2 x3. So show that the divided difference over x1 x2 x3 can be given by this formula, divided by x3 minus x1. Okay, so this one, if you remember the lecture, so this one is essentially we can draw pictures. Yeah, so how we do this. So if you remember, we can have, so suppose you have x1 x2 and x3 here. Yeah, okay, so then there is suppose you have 3 points here. Yeah, so fx1 fx2 fx3. So this one fx1 fx2 and fx3. Yeah, then if you remember, so the p1, yeah, p1 is the line that goes through x1 and x2. Okay, so then p1 can be written as f of x1. Okay, so f square bracket x1 actually just equal f of x1, okay, the value, yeah, plus the slope that go through, the slope of the line that go through 2 points, x1 x2, okay, multiplied by x minus x1. Yeah, so this is the equation of the line that go through x1 x2, written in the divided difference format. Yeah. And then you construct P2. So P2 now will be a parabola that go through 3 points. Yeah, so now P2 will be I don't have a green, but I have a red. So P2 will be is a parabola. Yeah, so parabola. So this one is my P2, and this one is my P1. Yeah, so P2 is parabola, and if I write down in terms of the divided difference, then remember, you know, I will have those two terms first. Yeah, so I got P1x, okay, plus the next term will be a divided difference over 3 points, x1 x2 x3 and x minus x1 x minus x2. Okay, so that is the the first two equations. But if you look at these pictures, I can construct P2 in another way, right? So this one is P2, I constructed from the left. I start from X1, I build it up to X2, and then I add another point. But now if I go from the right, yeah, I can start at the line that go through X2, X3, and then I build up, I build up the P2. Okay, so I will do that. So Q1, okay, so Q1 will be the line that go through X3 and X2. So what is my Q1? So Q1 is f of X2. Okay, so now I use X2 and X3, yeah, plus the slope go to X of the line that go through X2, X3. Okay, and X minus X2. Okay, remember I start from X2, yeah, I start X2, X3, so it's Q1. And now remember, because there's only one unique parabola that go through 3 points. So now P2 again, okay, but now because I go from the right, yeah, okay, so I will add, so I will start with my Q1 here. Okay, so remember Q1 is this line, yeah, the black one. And now I will add the divided difference, you know, X3, well, because I build up with X2, X3, and X1. So X1 now will come the, you know, to be the last point, yeah. So then this one will be X minus X2, X minus X3. So there's no X1 here, okay? There's no X1 here because X1 is the last point, yeah? And you never include the last point in the Newton form. So before, when you go from the left, then X3 is the last point. So you don't include X3 in the final form. However, it's still P2, right? Because it's still the same parabola that goes to 3 points. And now you have 4 equations, yeah? So say 1, 2, 3, 4, yeah? So 1, 2, 3, 4. Okay, so the idea is we will try to use 1, 2, 3, 4 in order to get out the divided difference over 3 points. Yeah. So how do we do that? Well, suppose I take P1 minus Q1. Yeah. So I take P1 minus Q1. So 1 minus 3. Okay, so I got P1 minus Q1. So I got P1 minus Q1, yeah. So P1 minus Q1, yeah. And if you do the algebra correctly, then on the right you got f x1 minus f x2. So minus P1 minus Q1, yeah. X1 minus x2 plus f x1 x2 x minus x1 minus f x2 x3 x minus x2. Okay, so I I leave it here, yeah. So what I can expand it, but I expand it later, yeah. I will do some expansion later. And now if I go back to 2 and 4, okay, so I take 2 minus 4, so 2 minus 4, yeah, so 2 minus 4, then P2 got cancelled, so I just got 0. on the left, yeah. And then here I got P1 minus Q1. So I got P1 minus Q1. So 2 and 4 is P1 minus Q1. And you have to do the algebra correctly. So you got x1, x2, x3, x minus x1, x minus x2, minus x2, x3, x1, x minus x2, x minus x3. Okay. So you see, so if you compare this and this, you know, I mean, P1, this one, P1 minus Q1 equals this, but this one is 0, is P1 minus Q1. So you can move this one to the right. I mean, you can move this one to the left and inverse, and negate the sign. Essentially, you get you get the same, yeah. So maybe we do that. So we say that this one just mean that P1 minus Q1 is f of x2, x3, x1, x minus x2 minus x3 minus f of x1, x2, x3, x minus x1, x minus x2. Okay. And now I want to compare this and this. Okay, but I don't want to compare all of them. I want to compare maybe the term, the coefficient for the x only. Okay, so I will have, so if I ignore the x, so I go back to, I go back to this, yeah. So if I ignore the constant, yeah. So if I ignore the constant, yeah. So there's some constant. So you see the constant is this one and this one, and this one and this one, yeah. So now I just focus on the term that have x. So I have f of x1 comma x2 minus f x2 comma x3. Okay, so it become x only, yeah. So plus some constant c1 plus c2 x squared. So I don't worry about that. Okay, I don't want to write down, but you see that the rest is just some constant and then some constant time x squared. Yeah, so we leave it there. Okay. And now if you go down here, I will do the same. Yeah, I will do the same here. So now if you focus only on the you focus only on the coefficient for x only. Okay, so I know that there is some x squared, yeah. Okay, there is some constant, but now if you focus only for the x only, what do you see? So here you will see that you have x2 well, minus x2x, yeah. Okay, so you have, so here you have f x2, x3, x1, and here you have, so I want to write down in terms of x only, yeah. And then I have so minus x3, so minus x3. Okay, so minus x3, and then this one gives me minus x2. Yeah, so minus x3 minus x2, and then down here you have this one as well. So minus x1, yeah. Okay, so now we have to be careful, yeah. So you have, so this one is x, yeah. So here you have minus f of x1, x2, x3, and here x. So this one is so this one is actually for the whole big bracket for x, yeah. So for x, then you have a plus x1. Okay. So actually this one is for the whole thing, yeah. Okay, so plus x1. And well, you have wait. So maybe still minus, yeah, minus x1 minus x2. So minus x1 minus x2. Okay, because minus, because we have a big minus outside already. So plus something, some constant and some constant x2. Yeah. Okay, you agree, yeah? But now, you see, now I want but now you look at this one. So we do one more simplification. So the divided difference over 3 points. Okay, I mean it's the same for for any orders. So actually this constant and this constant are the same. Okay, so you can have f x1, x2, x3. Okay, to be the common terms. Yeah, and now you got x2 and x2 got cancel here. Yeah, x2 got cancel, minus x2 plus x2 so got cancel. So what you have left is just x1 minus x3. Yeah. Okay, x plus c1, well maybe not c1 but c1 hat. Yeah, because we might have a different constant I don't want to write out those things. Yeah. And now you look back at this. So it's a previously you got P1. Okay, so you got P1 minus Q1, yeah, equal this. Okay, look at the red box, yeah. So this one is constant and x squared. So now we just ignore that. And now we go down here. You got P1 minus Q1. Okay. And you got this one for x. So because they're same polynomial, so they have to be, the coefficient have to be the same. Okay, so the coefficient of x in P1 minus Q1 are the same, yeah. So then you have f of x1, x2 minus f of x2, x3 just equal f x1, x2, x3, x1 minus x3. Okay, and therefore you have the formula. So therefore you have the formula for divided difference over 3 points, x1, x2, x3 equal x1, x2, x2, x3 over x1 minus x3. Okay, so that is the formula you have to prove. Okay. Yeah. So any question? So that is the formula you have to prove. Yeah. Okay. So if there's no question, then we move on to the next. Next question. Yeah. No question. Yeah. Okay. So now if I move to the next question is about quadrature. So next question is about quadrature. Question 3. So now question 3, then you have the integral e to the minus x f of x dx from 0 to infinity. So this is exact integral. Yeah. And the quadrature will be given by this formula. To f2 minus root 2 plus 1 over 2 plus root 2 f2 plus root 2. Okay. So now what is the degree of precision? Well, you have to do the calculation. What is E? So E of f will be the exact integral minus the quadrature. Okay. So now you have to do the integration. Yeah. So what is E1? So E1 will be integral of 0 to infinity e to the minus x dx minus 1 over 2 minus root 2 1 over 2 plus root 2. Okay, and this one, if you take the integral, this one it just gives you 1. Yeah, because it's 1 e to the minus x over minus 1 from 0 to infinity just give you 1. Okay, or this. And this one, so if you do the common common denominator, then this one just 2 minus square root 2. So will be 2 minus root 2 and 2 plus root 2, right? So what is just 2 square minus 2, right? And then here you have 2 plus root 2 minus root 2. Yeah. Okay, so this one it just gives you 4. This one gives you just 4 over 4. So 1 minus 1 just equals 0. Okay. And then e of x. So e of x is so integral of x e to the minus x from 0 to infinity minus, and now you have to put in the function. So now instead of putting 1, now you have to put in x. Yeah, so x will be 2 minus root 2 over 2 minus root 2. This one is 1 over 2 plus root 2 and 2 plus root 2. Okay, so if you do the calculation, then this one just gives you 1. Okay, so this one you have to do integration by part. Okay, but actually, I mean, if you if you look at the formula, yeah, so actually you can do this this side calculation first. Yeah, so you have in is e to the minus x times x to the n. Okay, integral from 0 to infinity dx. Okay, and then why? Because you have to do n equals 0, 1, 2, 3, 4, 5. So why not just do it for n? And then you will see that if I put u equal xn, right? I put v to be maybe dv, yeah, dv to be e to the minus x dx. Then what is v? So what is v? So v will be e to the minus x minus, yeah. And what is du? So du will be n x n minus 1 dx, yeah. And if you remember integration by part, then the will be uv minus v du, right? 0 to infinity, yeah. So this one 0 from to infinity. So what is it, u and v? So u is just xn and v is just e to the minus x from 0 to infinity. Okay, so this is just your integration by part, yeah. And minus v du, so become e to the minus x and du just n to the xn minus 1 dx from 0 to infinity. Okay, so you put it in and you will see that when it x equal infinity, yeah, this one grow faster than x to the n, so it just equals 0, yeah. So then what happened is only from x equals 0. So x equals 0, then this one just gives you 0, yeah. Okay, so this one should be n, it should be bigger than or equal 1. And then this one just gives you 0, yeah. And then this one plus, this one is just n time I to the n minus 1. Okay, so you got the formula. So in is just n time I to the minus 1 for n greater than 1. Okay, and I0 just equal 1, yeah. So because I0 is just e to the minus x, so you got I0 equal 1, yeah, and you got I1 equal 1 time I0, which is just 1, yeah, and I2 is just 2 times 1, yeah, and I3 is just 3 times 2 times 1, yeah. So In is just n factorial. So you see the pattern. So In is just n factorial. Okay. So now now you know that. So then this one just give you 1 again. Okay, because this one is just In with n equal 1. So this one just 1. Okay, so you do some side calculation and then this one, you see this one just 1/2 plus 1/2. So give you 1, so equals 0. Okay, so you do one more calculation. So ex squared. Okay, so now will be x squared e to the minus x from 0 to infinity, and you know that this one will be equal to, remember, yeah, and minus, okay, so now 1 over 2 minus root 2, but now you have the function will be 2 minus root 2 square plus 2 plus root 2, and now you have 2 plus root 2 square. Okay. And then you see, because this one, the 2 minus root 2 got cancelled, so you got, and 1/2 pull it out, so 1/2 here, so 2 minus root 2, so this one is 2 plus root 2, right, because it's got cancelled. So you got 2 plus 2 is 4, 4 divided by 2 is 2, so still equals 0. Okay. And then EX3. Okay, so remember this one is x3 e to the minus x dx. And now you just write down this one has to be equal 6. Remember the formula? So it's just 3 factorial, just equal 6, yeah. And then minus, okay, so you have to put in 2 minus root 2 cubed over 2 minus root 2 plus 2 plus root 2 cubed 2. Okay. And you know, because it got so one, so we'll go 6, and you got 1/2 coming out, and here you got 2 minus root 2 square, got 2 plus root 2 square, yeah. And this one 6 minus 1/2, and this one you have to complete the square, yeah? So you have to multiply out. So this one will give you 4 plus 2, yeah, minus 2 root 2, and plus 4 plus 2 minus 2 root 2. Okay, so this one like 6, 12 divided by 2, so still equals 0. Okay, well, it's a bit tedious, but still it's not too bad. I mean, if you do the calculation correctly, yeah. So now you got e to the x4, then you got x4 e to the minus x dx. So now, you know, this one is just 4 factorial, so 24 and minus, so now you got 1/2, and you got like 2 to the root 2 cubed plus you know, 2 to the root 2 cubed, yeah, because we got cancelled like before. And now, well, I mean, you have to expand it out, okay, but I can expand it out for you, yeah. So it will be like 24 minus 1/2, and this one is you got 2 to the cube is 8, yeah. So then you got 3 times 2 square is 4 times 2, yeah, and plus 3 times 2, then times 2, yeah. And then for the next one you have 8, yeah, no, sorry, and then minus 2 to root 2 cubed, what is just 2, yeah. And then the next one will be 3 times 4 root 2 plus 3, 2 times 2, and plus 2 root 2. Okay, so the root 2 got cancelled, yeah. And what you have here is just a plus 12, what is 20, yeah. Then 20 here, so 40 divided by 2, so 24 minus 20 equal 4, so non-zero. So the degree of precision is just equal 3, yeah, because E1 EX square EX cubed equals 0, but EX4 non-zero, so degree of precision is equal 3. Okay. Yeah. And now show that. So no, I mean now you don't have to show anything. So say that you have given this. So EF is the constant time the fourth derivative of some constant C. So it's given, yeah. So what is the constant M? Okay, so you know, you just use the previous answer. So you take F to be x to the 4. Okay, then you know that F to the 4th is just equal 24, right? I mean, you just take the derivative 4 times. You got 4 times 3 times 2 times 1, so 24. So then EF is just equal 4. We did it before, right? In the previous calculation. When you put x equal 4, error just equal 4. And equal M times 24. Yeah? Because it's 24. So therefore M is just 4 over 24. It's 1 over 6. That's it. Okay. Okay, so the last question is about ODE. So the last question is about ODE. So suppose you have Brunsch-Cutter method of order 4. Okay. So the table, the general formula is given, and the table is given. So this one you should be familiar with because this one is in the project, yeah. So now you have to write down only the way to compute the yn plus 1, yeah. So 1 over 6, 1 over 3, 1 over 3, 1 over 6, yeah. And then, okay, so this one is, we just write out xi1, okay. So xi1 is yn, and xi2 is yn plus h over 2. Remember h over 2 come from here, yeah. F of Tn plus h over 2 xi2. So one half come from here. So h over 2 here. And xi3 is just yn plus h over 2 f Tn plus h over 2 xi3. And then xi4 is just yn plus h f Tn plus h over 2. Oh, sorry. This one is not correct. This one should be xi1. Yeah, and there's no h over 2 here. Okay, and this one should be xi2. The xi3 depends on xi2, and xi4 depends on xi3. Okay, so Tn plus h because no, still plus h over 2 because this one is C1, C2, C3. So this one C3 is one half here. Okay, but this h is come from here. Yeah, the number 1 come from here. So you got this formula. Okay, and then you got yn plus 1. So yn plus 1 is yn plus h over 6 f of Tn xi1 h over 3 f Tn plus h over 2 xi2 plus h over 3 f Tn plus h over 2 xi3 plus the last term will be h over 6, yeah, h over 6 f Tn plus h is 1 is here. Okay, xi 4. So that is the formula for Orange-Kutta method of order 4. Okay, you should be familiar with by now. Yeah. And now the last question will be suppose I put in the following ODE. Put in the following ODE, yeah. And then I try to write down what is yn in terms of a polynomial q, yeah, time yn minus 1. So what is q? Okay. And so now you just have to plug it in. Okay, so you have to plug in the previous formula. So remember, you got xi1 equal yn. So nothing particular here, but xi2 now is yn plus, remember, f of Tn xi1, yeah, and with it just yn, yeah. And now what is f? So f is this one. So then it just yn plus h lambda. Well, I forgot the h over 2 here, yeah. Okay, because if you look the previous formula we wrote down, yeah. So yn so xi2 is yn plus h over 2 f of Tn xi1, yeah. So you write down, yeah. So then h over 2 lambda yn, yeah. So lambda yn over 2. Okay, and remember, you can label this one is z. So z is h lambda, and this one will be 1 plus z over 2 yn. Okay. And then you can put in xi3. So xi3 is yn plus h over 2 f of Tn plus h over 2 xi2. Right? So what is yn plus h lambda xi2 over 2? But because we got xi2 here already, so you just plug it in. And this one is your z, yeah, z is h lambda, so you got yn plus z over 2, okay, z over 2 here, and xi2, so xi2 you print it down here, so 1 plus z over 2 yn. Okay, so this one gives you yn, common term, so 1 plus z over 2 plus z square over 4. Okay, and the next one will be xi4. So next one will be xi4. So what is xi4? So any questions so far? So no question so far, so good. Well, so we will put in xi4, yeah. So xi4 will be yn plus h over 2 f Tn plus h over 2 xi3. Okay, and this one will be yn plus h over 2 lambda xi3. Okay, so you got yn plus z over 2, and now you just print out xi3 here. So you got 1 plus z over 2 plus z square over 4 yn. Okay. And now I can make yn to be the common term. So yn to be the common term. So I got 1 plus z over 2 plus z square over 4 plus z cubed over 8. Okay. And now I just put everything into yn plus 1. So remember yn plus 1 is yn plus the formula is h over 6 f of xi 1. So what is f of xi 1? Is just lambda xi 1 plus x over 3 lambda xi 2 plus x over 3 lambda xi 3 plus h over 6 lambda xi 4. Okay. And so now you have on the xi 1, xi 2, xi 3, xi 4 already. You just plug it in. So I plug it in, yeah. So I got yn plus, so h lambda is z, so z over 6. And my xi 1 is just yn. Yeah, so this one I got z over 3. And my xi 2 is just 1 plus z over 2 yn. Okay, plus z over 3. My xi 3 is just 1 plus z over 2 z square over 4 yn. Okay, plus, okay, so z over 6 xi 4 just 1 plus z over 2 plus z square over 4 z cubed over 8 yn. Okay, so now you can see that yn can be the common factor. So if you put yn to be the common factor, then the big gigantic open parenthesis here, then what is the term that gives you a constant? Just 1, yeah, 1 here. And what is the term that gives you z? Well, 1 over 6 here. Okay, and then you have 1 over 3 here, yeah. Then you have 1 over 3 here, yeah. And you got 1 over 6. The last one, yeah. So what term gives you z square? Well, z square, you just have, so 1 over 6 here, yeah. Come here. And this one is 1 over 6, yeah. And this one gives you 1 over 12. Okay. And what gives you z cubed? Well, there's no z cubed here. So just 1 over 12. And this one is 1 over 24. Yeah, that's it. And what gives you z4? So z4 is just this one. So so z6 and 8 here, yeah. That's correct. So that last one will be let me check. So this one is, so let me double check, yeah. So z3, so xi3 is 1 plus z over 2 z square over 4 is correct. Xi 4 is no, xi 4, this one not h over 2. I think xi 4, this one is only h. Okay, sorry about this. So we didn't do this one correctly. So this one only h here, and then you have only z here. So then if you multiply in, then z. So this is 1, and this one is only z, yeah. And this one is z squared over 2. Okay, and this one is z cubed over 4. Okay. So now we have to correct this. So this one is only 1, and this one is only 2. This is only 4. And this one is only 4. Okay. And then, okay, so now we have to adjust the last one. So this z is still correct, yeah? How about z squared? So z squared, you have the last one. So this one is 1 over 6. 1 over 6, and the last one is 1 over 6, yeah? Okay. And for z cubed, then you have 1 over 12, and the last one is 1 over 12. Okay. And for z4, then the last one will be z4 over 24. Okay. Yeah. And now you sum it up, yeah. So this one, if you sum it up, this one is just 1, right? 1 over 6. 1 over 6 is 2 over 6 is 1/3. Just give you 1. And this one is 3 over 6. It just give you 1/2. Okay. And this one just give you 2 over 12 is 1 over 6. Okay. And then this one is 24. Yeah. So it's correct. Okay. I think that is the end of the exam. Yeah. So any more question? Okay, no problem. So we stop here, yeah. So stop recording.